Welcome to Groundwork, a podcast from McClanahan Corporation to talk about key material processing topics. From agriculture to mining to material recycling, we'll discuss the best ways to process the raw materials that power the world, because if it's not grown, it's mined. Hi, my name's Nick Ford. I am the Director of Sales for the Aggregate Crushing and Screening Division with McClanahan Corporation. I have been with the company a couple different times. This is the second time I've been with this company. This is that's about a little over 2 years now since I've started for my second time. Previous, I was with a company called Universal Engineering, which was acquired by McClanahan in 2012. So in that particular company was out of Cedar Rapids, Iowa. So now I'm still in Cedar Rapids, Iowa, but dealing with the product line. So we do have another person here. That would be Jack. Jack, do you want to give a little intro?
Yeah, hi, my name's Jack Robinson. I'm lead design engineer for screens here at McClanahan. I'm based over in England, closer to our European headquarters in Northern Ireland. And I basically lead most of our design and development efforts for anything to do with screens. So spending most of my time developing those, kind of working with Nick, with yourself to design products that are going to solve problems for our customers. We've got a small team of engineers over here working with me, and I've been at the company for about coming on 3 years, I think, which is quite mind-boggling.
I forgot to mention, how long have you been in the industry, Jack?
I've been doing this for just under 12 years, but that's basically all my working life. So I was kind of finished my education, dust around for a little bit, and then I got into screens, and that's all I've done ever since I've worked on screens, and pretty much nothing else in engineering. So
Gotcha.
Yeah.
I forgot to mention, I've been in the industry for nearly 20 years. Was with a competitor, sort of, that focused on portable track plants. So quite a bit of knowledge in crushing and screening, seeing the goods and the bads, probably like you, Jack. So appreciate that. Our topic, we just kind of go through what we're going to talk about today. We're going to talk about screening success and kind of how to choose the right aggregate screen. Why this topic? Why do we want to talk about this? I don't know about you, Jack, but I see several customers, and it seems like screens are always kind of their headache in the process, So, I don't know if it's that they've grown or maybe didn't do their homework when they purchased the screen or what have you, but it always seems to be the issue. And how about your experiences?
Yeah, it's definitely the case. I think a lot of the attention gets given to crushers and not too much to screens, isn't it? I think typically they're more expensive. They're more expensive to initial costs and more expensive for the running costs. And I think screens are kind of just something that you buy to put the plant together, and it's built around the crusher. So I think they don't get as much attention as they probably deserve, and I think as a result of that, you obviously meet people who know tons about screens, but people tend to. There's a lot of misconceptions, I think, around screens. There's a lot of stuff that people assume, or they might have a limited experience has affected their view on screens and might not know kind of what else is out there, what other options there are with screens. I think typically it's not just knowing like what's the right screen either. It's setting it up in the right way. That's the other thing. People tend to not be too confident in what they should be looking at, what characteristics of the screen affect what outcome. So hopefully we can talk through some of that.
Yeah. And speaking of that, let's talk about some of the topics we'll cover. We're just going to, what is screening? We'll talk about that. The types of screens. What are the various types? Why choosing the right screen is critical. Spend some time there. And also factors maybe to consider when choosing a screen that, are very important. Screen media, obviously there's multiple options to choose from. Let's talk about kind of why we choose those. And then the fun part, the examples of maybe some of projects that we had worked on in the past and successes that we've had, or maybe some things we've learned on too. And then we'll wrap it up from there. But anyway, let's start here, Jack. In your mind, what is screening? What do you think the definition is?
I think the definition is pretty simple. The two words you hear most often is stratifying and classifying, which effectively just means sorting. So you're sorting different particles out from each other into different groups based on their size, usually. So that's all it is. I think the probably the thing that most people would have like experience with out of the industry is a sieve that you would use for sieving flour or whatever when you're making a cake. That's probably the most basic form of a screen, isn't it? You're sieving it, you're removing particles that are over a certain size and keeping the ones that are below a certain size. So it is to me. I think it's probably been around for thousands of years in one form, but more recently it's produced into the problem with that type of sieve is you've got to do it in batches. So you've got to fill it up, sieve it, get rid of it, put another batch in. So that's why it's then developed into a vibrating screen as most people would know them now, because it's effectively a sieve crossed with a conveyor. You can now do it continuously because you're putting it on at one end. The material is continuously going into different chutes, and you can just do it all day, every day.
It's kind of the money-making device, right? So I always picture screens. You see the old miner, he's sieving the gold from the river or whatever, the stream, and he's trying to get that gold, and that's the money. Crushers are awesome. They're fun, but they don't make you money. They cost you money. And this is the one thing that puts, it can make your specification or whatever it is that you're trying to do. That's what you can sell. And to me, it's the money making.
Yeah, you could probably say that the crusher determines kind of like what products you can make in aggregates, and then the screen determines the quality of it and what you actually sell. I agree with you there.
So, Jack, what do you think? There are, there's so many different kinds of screens. We got, horizontal and possibly incline. Is there any others that come to mind?
Dewatering screens are probably the most common one that it doesn't. You could call it a horizontal screen, but the way it kind of the working principle of it is slightly different and what it's actually doing. So you've got dewatering screens, and I suppose you get lots of variations of those three screens. So you get flip flow machines and high energy screens and different, but most of them are going to fit into horizontal, inclined, or dewatering. I would say, and there's kind of which one you want. Pretty much depends on what you're trying to do, I suppose.
Yeah, because inclined, you could have, let's say it's a scalping screen that's taking a bigger material. Probably wouldn't want to put that on a lighter duty, maybe what we call finishing type inclined screen. So, you'll see some variances when it comes to like you said, Jack, the different products and what are you trying to do with it. So if it's more coarse and like a riprap type maybe situation, maybe it's a lower incline at 12 to 15% degrees versus like a final screen, if you want to call it that, or a classifying screen that's trying to get the small, let's say 25 or 1 inch down, or that's going to be more at like a 20 degree type of incline. And obviously your horizontal, that's flat. I am starting to see some that use the horizontal at like a 5 degree or 10 degree situation too. So, and people ask, what are the differences between the two? What do you think, Jack? How would you respond to that?
You could describe the differences probably in two different ways. One is like what it's doing like within the application, the way it processes the material, and then the other major difference is the way it generates the vibration in the first place, the actual mechanism that does it. So I think an incline screen is probably the easiest to explain to anyone that's listening that doesn't know what a screen is in like its most basic form. But effectively, it's a big sieve, so like we call them decks, and they've got holes in them of a certain size. Material less than that size will pass through it, and anything bigger will pass over it, and then eventually end up in the chutes relevant to what size it should be. So, and you can get different numbers of decks stacked on top of each other. So typically you'll have 2 or 3 in most kind of aggregate processing applications. So on an incline screen, what you're trying to do is, if you picture the sieve again, you're trying to shake the material effectively so that it hits the deck and then goes back up into the air, hits the deck again, goes back up into the air. And the more times you do that, the more opportunities you give a particle to pass through the deck. So that's what you're trying to do, but you're also trying to convey it along the deck from one end to the other, so where you feed onto the deck to where it discharges. So to do that on an incline screen, the easiest thing to do is to just use gravity. So it's tilted forwards and the material moves along the deck as a result of gravity. And an incline screen, you would typically use it for like higher tonnages where your efficiency, the efficiency that you're after, isn't quite as critical as tonnages. I think in everything in engineering, but really massively in screening, everything is just a big compromise. Everything you try and do is a compromise. So you can't do everything perfectly. You can't screen really efficiently, but in a compact screen that uses low levels of energy and doesn't wear, you can't do everything. So you have to decide on what are the things that are like the most important. So an incline screen you would typically use when you're not too bothered about processing the material efficiently, as in some material might not get sorted that you would want sorted, but you want to do higher tonnages. The horizontal version is pretty much exactly the same, but instead of using gravity to convey the material along the deck, you control the way the screen vibrates. So it vibrates in a linear or elliptical way, and that material gets thrown by the machine up into the air and forwards. So it kind of, usually about 45 degrees to the ground, gets thrown along the deck, and it hits the deck, gets thrown further, hits the deck, gets thrown further until it's reached the end of the screen. So there are 2 main differences in the way that the material gets actually processed, but the mechanisms are different, right? That's where you'll see a lot of people doing similar things. On an incline screen, it tends to be just a single shaft going through the screen because that's the cheapest and easiest way of doing it effectively, and it minimises the amount of components. It's pretty simple to manufacture, simple to maintain. A horizontal screen is a little bit more complex because you've got to generate linear motion to control where the material is going. So typically you would use more than one shaft, and then you introduce more like complicated components like gears and timing pulleys or different components into it. And that's where the compromise is usually, that it's a horizontal screen, usually more expensive, usually more complex, but there's a lot of benefits to it as well. So main benefits, they're like head height. They tend to be capable of operating at high G-force because they've got to throw the material up and forward as opposed to just up. So it's better for sticky material. But is there anything I've missed? I think you.
No, I think you hit most of it there, Jack. Horizontals, kind of the obvious thing. It's kind of, like you said, we sometimes have to compromise, right? When it comes to some screens and incline screens, it's a little harder to, let's say you want to screen it 1 inch or a half or 25 mil or 12 mil or a half inch, it's a little more difficult because you got to deal with the angle. So now you have to figure out, with a 20-degree angle, that let's say half inch isn't truly half inch, because the more the angle, the actual smaller the hole or the aperture of the screen. So that's you have to do some math there. Now, obviously horizontals, you don't. It's sitting flat, so that half inch is a true half inch or 12 millimeter or whatever it would be. So that's kind of nice. I guess not really advantage, but just for a guy like me that doesn't like to think or do math, it's perfect. But you're right. The mechanisms are really different. You'll see a lot of the horizontal screens have like a triple type shaft design versus, a smaller incline, like a 5 or a 6x20, let's say, with like a single shaft. And even the bigger incline screens, you do kind of see like a dual shaft as well, but much different. You're right. Don't have to deal with the gears. Inclines are kind of cool too, or horizontals, because you can adapt the mechanism to whatever material's being fed on it too. So if you've got a small material, you can change, the gearing to give you a little bit different angle, and then also change the amount of throw as well. So, each screen has their place, no doubt.
Yeah, they do. They do. I would say your starting position should be to use an incline screen unless there's a reason not to. So I'd say start with an incline screen and think, why could this not do the job? So purely based on the fact it's cheaper and it's easier to maintain and run. That I think should be the main starting point. And then you think, well, actually we need to be able to screen more accurately, or do we need to go to, is it sticky? Do we need high G-force? Do we have the headroom to have a screen that's as high as an incline screen would be?
Yeah, North America, we see a lot of horizontals just because of the fact that they're on portables, so that's a big advantage there. But yeah, it's a good point. So why do you think, Jack, why is choosing the right screen critical? I mean,
it's because he's going to spend money on it.
Yeah.
I can guarantee if you choose the wrong screen or if you choose the right screen but don't have it set up in the right way, it's going to cost you money somewhere. Whether it's if you're operating the wrong speed and stroke, then it might be that you're using more motor power than you could be getting away with, or your decks might be wearing slower or faster than you can get away with, or you're not screening efficiently enough. So I think like the main reason is cost, like the initial cost. If you go with one type of screen, design your plant around it, it's difficult to then swap. You can swap to different variations of a horizontal screen, but it's difficult to then swap to an incline screen or vice versa. So you've got to get it right first time. So you've got to consider it, and you've got to use all the resources you can to make sure you do get the right screen.
Yeah, it's like any tool. Whatever you want to, you don't use a hammer for, raking the garden, right? So let's get it right the first time.
Yeah, exactly. And I think that there's no, like most OEMs, most screening media, most operators, there's enough information out there nowadays that you can spend the time and make the right decision initially. You just need to start with like the right mindset that you can have a think about it and go for it, like aim to get the right screen. And if you do stuff properly, there's no reason why you can't start off with the right screen. There's always going to be some assumptions that you have to make. I think the easiest thing to think in this industry is that all applications are the same. Every sand and gravel plant is the same, or every asphalt plant's the same, but it's just not the case. Everything's slightly different in some way.
Yeah. I don't know about you, but I've had people say, hey, every screen's the same, and then they put it in their application and it's a nightmare. And maybe they didn't account for sticky material, and it's just a mess, Jack. You know how it is, and they fight it, and they're they've spent hundreds of thousands of dollars, and now they're in trouble. So anyway, I agree.
Exactly.
Pretty critical.
Yeah, it's critical.
And you know what? That kind of leads into the next topic. Some of the factors to consider when choosing a screen. I don't know about you, but when I talk to customers, they want a price on a screen. Let's say I have a million questions to ask. Because there's so many factors to consider, like tons per hour. Anything else you can think of, Jack? What do we need to know to give them the right tool?
Typically, if we were quoting on a machine, we'd want to know what material they're starting with. So what material it is, the density, the split size of the gradation, as in what percentage of it is a certain size. You'd want to know what moisture content it has, and whether that's going to kind of vary throughout the year. So in the winter, is that going to get wetter and stickier? Or so you'd want to know that, and then you'd want to know perhaps where the actual machine is going to go. Is it going to be in a hot environment, cold environment? There's all those things is what you would start with, and then you can start looking at, again, like I say, what screen it is you need, what type of medium on that screen. I think that's it. There's nothing.
That's a good point. A lot of people don't think of the weight of the material, and they get that screen in place, and let's say I go pounds per cubic foot is my terminology I go with, Jack. And limestone, I always go with that. It's 100 pounds per cubic foot. And it could be somebody that has like coal, and that's half the density, or the weight, I should say. And you really don't think about, okay, so if I'm half the weight, and I want to do, let's say 300 tons an hour, you have to consider that half weight and actually take the tonnage and double it. And 300 becomes 600 tons an hour, and that maybe 5 by 16 is just not going to work.
It's a good example of that is a project we're looking at the moment over here in Europe, where it's a company that are processing something similar to geosol, if you know what that is. It's like an aerated rock used in as like an insulating layer typically, but it's really lightweight. So it's hard, looks like rock, and is typically in balls, but actually it's about an eighth of the weight of gravel, like sand and gravel. So but it takes up so much more room on your screen. The bed depth's massive. Sizing it's dead important. It makes a massive difference. The ton per hour you can achieve is a lot less on the same size of screen. There's a lot of stuff. I think moisture content's often ignored. I don't know what it's like in the US, but over here that like obviously we get a lot of rain in the UK and in Europe. Depending on where the plant's going to be, the moisture content can massively vary, and that does play like a huge role in mainly what size the screen can be. But again, like what media you need, what type of screen, whether it needs to have like a lot of force to, if it's sticky, it needs to be able to throw it out the apertures and it's not going to stick. The moisture content is the other one that tends to get ignored. It's typically quite easy to get your size gradation, but the moisture content is not always the one that's easy to come by.
Well, I have people say, hey, I've got, I have a 5 by 20 screen and I want to do 1,000 ton an hour. That should be able to handle that, right? And I don't know about you, but I mean, it depends on, I have to say, well, what do you want to separate, right? What do you want the screen meshes to be, or split, like you said, Jack? And, I just want to do let's say 5 inch, the next deck will be 1 inch, and then the next deck is an 1/8 inch, or something like that, or 2 mil. You have to. So another thing that I always keep track of is the splits. Let's say your top deck, they want to have like a 4 and a 5, or maybe even a 6 inch. Is it a good idea to have maybe a 1 inch in the middle? Is that reasonable?
Yeah.
Or is there a rule that you should, is there a split rule, like a 3-to-1 or something like that, Jack?
I don't really know of any rule, like rule of thumb. But again, the compromise you make there is, if you say you're operating with a triple deck machine, you need to know what speed and stroke to run that machine at, and typically that's going to be governed by what your top deck is. And that's the reason for that is because you want to avoid pegging. Pegging's where you get rocks stuck in a hole, and it's not going to, the screen isn't pushing it out again. So that's what you want to avoid. But if you increase the stroke to avoid that, then your lower decks become less efficient because the material spends more time in the air, even though there's no chance of those lower decks becoming pegged. And then you reduce, although you could do all the calculations you want on sizing the screen, if you then don't operate it at the right speed and stroke for the application, then or like the ideal speed and stroke for that cut size that your deck is for, then the sizing that needs to be accounted for when you're sizing it. You would have to go to a bigger screen. But yeah, your question about having a deck to, you call it a relieving deck, don't you? Having a deck to basically remove some of the upper sizes from what the deck sees by having a deck above it that prevents all of the material going onto that bottom deck. That can be like an effective way of keeping the screen size down. The cost implication is that you have another deck, you don't have to have the media for that deck. But if you're looking for like high efficiencies but on a relatively small footprint, that's a great way of doing it. Yeah.
Yeah. And another thing, let's say that customer wants that such large split, like a 6-to-1. That's a total example. But, I question, how much there is of the passing material through the top deck, because when you get into smaller screen mesh, which we'll talk about here in a little bit, that big material bouncing or hitting, passing through and slamming into that middle deck or the lower deck can damage that and be very expensive. So, you need to look at that and account for that too. But in the process, Jack, let's say you've got your feeder, your truck's dumping into the feeder, going to a crusher. Where are screens used in the process? Where are they used in the plant?
Get them basically throughout the plant. So typically you'll have them before crushers acting as a scalping screen. So you want to remove a certain size from the crusher. Typically you're removing fines so that you're increasing the life of your wear liners on your crusher. So you'll see that, and those type of screens tend to be high tonnage as the aim, but not necessarily a focus on efficiency. So that's where you might usually, well, almost always, you're going to see it as either an incline screen or as a grizzly scalper screen, which can be horizontal or inclined depending on how it's set up. But so you get them before crushers, but then you will have them further downstream, typically then sizing your product. You might be using it as a wash screen, but typically you're using it as a wash screen and sizing your product at the same time. It's rare that you're just taking out.
So it's not unheard of to have like 4 to 5 screens in the whole plant or more.
Yeah, definitely.
Yeah,
depends on like you can go to sites with 20 screens on it, but yeah, it depends on the tonnages they're doing. Typically, people will more often than not, it's better to have 2 smaller screens and 1 big screen doing the same thing, because then you've got protection against one of them going wrong, or you can always keep some material going over the plant. But it's good for keeping like the footprint of your plant down and the height of it down.
Is it kind of important to is there a way to feed these screens properly? Is there a right and wrong way to feed these screens, do you think? Or
yeah, there is. There's like how much it matters depends on the specific setup and the application. But the majority of the time you want the screen to be fed in a way that protects the screen from damage as it's getting fed. So you don't want material falling a long way before it's landing on the screen. A screen in relation to a lot of what's on a mining application or quarrying application, a screen is a relatively lightweight piece of equipment. And the reason for that is obviously you've got to shake the whole thing. So if you make it heavy duty, it's gonna take a lot of energy to keep it going. If you make it too light duty, it's not going to last very long. Because there's like a middle ground, but typically they're lightweight compared when you consider what they're doing. So if you then go and like feed it any old how, you can damage the screen quite easily, and you can wear the media down if you're feeding it incorrectly. That's the main thing. So if you're feeding it directly onto the media, where the materials land, then it'll just wear quickly, and you end up having a maintenance headache and the cost that comes with it. So typically, most screens you'll see have a feed box. So a feed box is like a box at the back of the screen on the top deck, and it's just a big impact panel to have rubber liners or Hardox liners or like a hardened steel liner. Material hits that, and then it's used to spread the material out across the width of the screen, so that when it comes onto the screen onto the part of the deck with the apertures, it's all nicely distributed, and it comes onto the screen evenly. So that's like the ideal setup. Dewatering screen is a little bit different. Dewatering screen, you want to like slide the material across the back of it. They typically have a slope section at the back, and you want to slide the material across the back of that. On your normal inclined horizontal screens, you want to feed it into that into the impact section on your feed box, let it spread out and come onto the screen at like a gentle pace.
There you go. You don't want surges. You want a gentle, consistent feed, right?
Exactly. Yeah. Exactly. Okay. And you will see I see so many instances of that not being the case.
Yeah.
Where people have got a brand new screen in and then just set it up with a feed that's going to damage it in like half the amount of time it should be lasting, or it's perhaps the conveyor's coming in from the side as opposed to move it, so the materials getting fed down one side of the screen instead of evenly across the whole deck.
Yeah, and I suppose mounting the screen is kind of important too. So you probably want to have a pretty level structure. I mean, I've seen some customers where if it's on portables, this happens quite often where the ground is unlevel, especially like a track machine, and they'll actually be tilted to the side a little bit, maybe a few degrees, and that material likes to run to the low side. That's fairly important, would you say?
Oh yeah, definitely. I think track plants tend to be able to. They'll have their springs set up, so their isolation mounts set up in a way that can perhaps deal with it a little bit more than on a static plant. But your typical screen going into a static plant, it needs a nice level structure, and it needs everything to be solid and square. And
if it's not square on a stationary or static, then probably need to go talk to whoever put it in. Get the levels out, guys. How about screen media? Let's this is a topic that's interesting because there's so many different types of screen media to choose from, and in my experience, this is where the questions really pay off. And I know of multiple. One's not more popular than the other in my view, but Jack, give me ideas. what's out there for media?
Yeah, the media really is, when we talk about compromise and like what the pros and cons are. This is like the biggest area of it on the screen. This is where you'll see you could spend a little bit more in your initial costs, but then you perhaps recoup that cost by how long that media lasts or the way it performs, or vice versa. So the the probably the one that's been around for the longest will be woven wire, and that's it's just a big, it's wire going in one direction and then more wire going in a perpendicular to that, and that creates apertures, and it's pretty versatile, and it can be made in lots of different wire thicknesses depending on how much you want it to, how slowly you want it to wear, and it's quite easy to get it in different aperture sizes. So for different products, you can get it in different aperture sizes. It's like pulled across the deck, tension from one side to the other or from one end to the other to keep it from flapping around on the screens in operation. And the benefit there is it has high open area, so it's got a lot of open area in relation to how much area the whole media covers on the deck. Um, and they're typically pretty cheap, but the con is that they wear quickly. That's the big con, and they're not great in wet applications because it's steel
Stick.
normally.
Yeah, I've woven wire. Yeah, that's probably the most popular that I see out there. It's, and people that don't know what that is, it's basically, think of your grandma weaving up and down and all the way throughout the screen, and then you've got pieces crisscrossing like that too to create a square opening. And it's so basic, but yeah, you're right, Jack. If you've got too big a material and maybe you're feeding onto it, it can, kind of make that screen move out of play. The weave, if you want to call it that, come undone. So you really have to be careful and kind of know what your size is. But you can also get it in different materials as well, I think, right? You can get maybe in stainless steel, and maybe urethane dipped
There's
or
a lot of like variations of it as well. You get like self-cleaning versions of it and different like patterns of weaving depending on what you might be trying to do. Some are more accurate than others, but perhaps deal with sticky material better. Some more accurate than others, but perhaps wear quicker than others. Yeah, that's the first time I've associated with my grandma, though, I think.
Hey, gotta throw one in there once in a while. Oh man. So I mean, woven wire is probably your biggest one that you'll see out there. And again, when you have sticky situations, it literally will stick. So I've even had people put on, they'll say, "Oh, I use this, and I put chains on this on my screen, and the chains will actually sit there and shake sort of with the screen, but kind of sweep it right to clean this material out." Have you ever seen that before?
Yeah, I've seen some. Well, you get declogging rods, which are like
Declogging rod. What is that?
I think that's what they're called. You don't see them very often, but it's basically it is like a chain with PU wrapped around it that just dangles along the deck.
What's PU? Is that a skunk?
That's it. That's a good question. So that polyurethane, so it's wrapped in polyurethane, and then they kind of hit the deck and just give it an extra bit of a shake, and they swing from side to side kind of thing, and loosen up any sticky material. They're definitely seen as more of like a band-aid than a solution. You kind of do that as a last resort when you're in a bit of a sticky situation. But
good one, Jack.
Yeah, no pun intended.
You can do it too. How about polyurethane? When would you use that? I mean,
yeah. So polyurethane, I think over here, it's like probably the most common media that you'll see beyond woven wire. Polyurethane's good in so polyurethane is what it is it's a like a panel that or typically comes in panels. Sometimes you get it as tensioned, like side tensioned media, but typically it comes in a panel, and you install a lot of them across your deck, and it's cast PU, and it'll have openings in it, depending on what product you're trying to make. The benefit of it is there's a few benefits. It's handy that it can be cast like relatively accurately, so you can, when you get down to the smaller cut sizes, it's good because you can cast it with a good level of accuracy. But it's also good in like abrasive applications, in especially in wet applications. That's when you would typically use it. So 9 times out of 10 on a wash plant, you're going to see PU.
Okay, so when you say wet, though, does that mean the material's wet, or is there something like in the system?
Yeah. So if you had, if you were washing if you were using your screen to wash the product, so you were trying to force the fines through the decks. So think of sand and gravel, trying to get the finer stuff, the sand off the gravel and push through the decks. And you'd use spray bars through a screen. So it's just a bar that goes through a screen with lots of openings on it, a bit like a shower that pouch your material with water, push it all down into the underpan, so the chute underneath the screen.
That's materials to take showers too to get clean, right?
Yeah,
makes sense. Yeah,
exactly. Yeah, not too much sand coming off me, but yeah, definitely do. And then and the benefit is that it's like PU is good when it's wet because it like material slides off it nicely.
Okay.
So
Okay.
then it doesn't, it kind of works its way along it easily. The next common one would be rubber, which does kind of the opposite. That's rubber's good in application. It's used in a similar way in that it's panels or sometimes side tensioned, but that's good with more like impact loads and gouges and resisting like big rocks trying to cut into it. So that's where you would weigh up the pros and cons of rubber versus polyurethane. If it was wet, you're probably going to use polyurethane because it slips away from it, and instead of cutting into it, it just slips away. Whereas rubber is good when it's typically like bigger cut sizes, and it's going to get big sharp rocks hitting it and trying to cut away at it.
Sure.
So the downside of both of them over woven wire is that you typically will have like a smaller open area, so less aperture for the material to go through. So you would need a bigger screen than.
So the 500 tons an hour that I had maybe with woven wire is going to be a little less?
Exactly, yeah. Exactly.
Okay. So you might need to know that. Okay.
Yeah. And then they'll typically last a lot longer as well than woven wire. So So perhaps might need a bigger screen, but it's going to be a lot less maintenance and a lot less work to get in there and change it. So they're probably the three most common: woven wire, polyurethane, and PU, and rubber. Sorry.
So we should know a little bit, if you're a person that has a screen and it's wearing out because you have abrasive material and you want to go to poly or rubber material, then you'll need to know the open area and make sure it works. So it's good to know that. That's huge.
Yeah.
So you might save, on your downtime changing the screens out, but now you've got less production. So not fun.
Exactly.
What costs you less, right? So, there's other screens out there that I've seen. I've seen some, like you said, self-cleaning. I think you said, Jack, self-cleaning wire. Give us details on that.
Well, self-cleaning wire just tends to be like it's arranged in a way where the wire can move the wires can move in relation to each other a bit easier. And then what that does is if material kind of clogs up the opening, the wires moving slightly then allows some of that material to come out of that clogged up state, so it will either fall through or come back over the top of it and move on down the deck. The con of that is they tend to cost more, but they're less accurate because it'll open up to let stuff through. So typically you will have to use a smaller aperture size to do what you want to do, which then means that you're going to get potentially like you're going to get like a lot of stuff that could be going through the deck just carrying over the deck. So you have to kind of weigh have a look at that properly.
Have to know what your specification is, and if it's really a tight specification, a DOT spec or something like that, you should kind of be wary of that. And speaking of that, like let's say you're trying to hit a specification. Have you ever heard of anybody that's maybe using separate or different kind or size panels throughout the same deck? Like let's say they have one end, they have, I don't know, 1/2 inch or 12 millimeter, and then the next one's maybe a different size. Have you ever heard of that?
Yeah, you see it. You see it actually quite a lot where they'll open up apertures more often than not. The product that you're trying to make allows for some some level of contamination. So some producers will open up the apertures on a deck to allow some oversized through because they can get away with it, and it's become sellable in their product. So that's a good way of maximizing what you can sell. So, yeah, you'll get that, and then obviously like relieving decks is the other common place that you'll see that the decks that we talked about earlier, where you'll have one deck purely just to minimize the bed depth that's on the deck below it, and perhaps that'll further down the deck let some more material through. You do see it on asphalt screens. It's quite common where an asphalt screen might have like three and a half decks, for example, and it could be producing 7 products depending on where the shoots are arranged. And so quite often they'll have split aperture sizes across the decks. Quite common.
Perfect. Well, I'll tell you what, we're getting close to the end here, Jack. I don't want to, you're talking a lot, I know. I guess one thing to clarify, 1/2 a deck, do they actually make a screen with 1/2 a deck, or what is that?
Yeah, so on asphalt screens, you'll see it, and it's quite common. You don't tend to see it too much in quarries and in mines, but in asphalt screens where they're often just doing a screen of relatively low tonnages, but they want to split into different sizes before they put it back into their mixer into the asphalt that they sell. So they can kind of get away with having one screen that splits the material, separates the material into lots of different sizes. And one way they do that is one way a lot of OEMs will do that is by having a half deck at the discharge under the screen, so that you imagine it. So say you've got a half deck under your top deck, you'll get some material that goes through the first half of your top deck, and that will go down to your bottom deck. But if it makes it to the second half of your top deck before it goes through, it then falls onto your half deck. So it just allows you to make another product, but you're limited at how efficiently you can do it and how much tonnage you can do, because there's only half a deck to do it on.
Right.
So it kind of needs to be sized properly. In asphalt plants, you can usually get away with it. So it's a nice way of keeping your screen relatively compact, but producing more products.
Well, let's jump into the next we call bespoke screens or custom screens. I don't have a ton of experience with custom screens, but there's a lot of customers out there that maybe have something from 1980 or something like that they want to replace. It doesn't, the 80s felt like yesterday to me, but most people think that was a long time ago, which it's kind of a bummer. But anyway, so Do you have any? Have you done very many custom screens in your time with McClanahan, or any interesting ones to talk about?
Yeah, we do over in Europe. We do a fair few of them actually. We do. Obviously, there's quite a big market for it because there's a lot of screens out in the world, and there's only a limited amount of life that you can get out of a screen, and at some point they need replacing. And the benefit of doing a custom screen is that you can replace a screen with something that's designed specifically for an application, and in a way that you can minimize your downtime when you install it, because it perhaps picks up on the exact same footprint as the previous screen, uses the same shoots as the previous screen. But when it's the most effective is when when you've got a setup that is, you know the issues with it, and you know what the customer's trying to do, but you can effectively upgrade what they've got. So you're not just replacing it with a like for like machine. The best use case for a bespoke screen is when you replace it with an upgrade. So that can be anything as little as just improving the access to the screen, or improving how certain bits of it wear, those kind of things. But more often than not, it can be when the customer is trying to change what they're doing with that bit of the plant. So perhaps they're trying to put in another deck because they want to make a new product, and they want to rearrange some of the shoots. Or
didn't you make one or design one that had like a 4 or 5? I think it was 4 decks, if I recall. Which is, maybe you did something even more.
Like a really good example of one that we did recently is out in Norway. We had a customer who basically has a hopper in their quarry, and then they were currently using a feeder underneath the hopper to feed a jaw crusher, and the undersize was going to a cone crusher, the oversize was going to a jaw crusher. And they were cutting at 130 millimeters cut size, and in 99 times out of 100, you see that situation, and it'll be a grizzly feeder under the hopper, and that'll be feeding the jaw crusher. But in this situation, what was going through the screen was going to a cone crusher, and they couldn't afford to have long particles going through the screen, so they couldn't use grizzly bars because they needed them to be like relatively uniform in their dimensions. So it had to be a punch plate deck, or like instead of a grizzly. So the problem with that was they were doing it with a screen, so that there was a lot of material sat on the back of the screen because it was under a hopper. So that the back of the screen was just pinned down, not moving, and then the front of the screen was flapping around all over the place. It's kind of a bit of a Frankenstein of a setup, because it was all obviously second-hand things to start off with. But they were like a big company, and they produce a lot of material, and it was an important part of their plant. It was their primary piece of equipment, feeding a massive feeder and a massive cone crusher. So what we did there was, instead of replacing that screen with another screen, we replaced it with a small feeder and a scalping screen. And what it allowed us to do is, the feeder could take the material out of the hopper, and then it freed up the scalping screen to just operate as a screen instead of being pinned down by the material in the hopper. And then it meant that we could put a big stroke on it. We increased the cut size from 130 mil to 150 mil.
Wow.
And on that, the customer was feeding their plant through that with about 2,000 tons per hour.
Whew.
And we increased it to 3,000 tons per hour. So like, it made quite a significant difference. It also gave us like the chance to talk about like the way that they maintain it, and gave us like the opportunity to design in certain features that they requested, like extra thick liners here and extra thick liners there, and like inspection ports here. And that was a really good example of it, because it's something that just you couldn't, because of the space limitations, you wouldn't be able to do it with like products just out of a catalogue. It had to be a custom, bespoke, like one-off machine, and it was that's been pretty successful. The other good use case for it we're seeing a lot of traction with at the moment is on asphalt screens. So
Yeah.
typically, like a lot of asphalt screens are, there's a lot of old asphalt screens over here in Europe that have been around for perhaps 20 years, and the plant's fine, but they've started to process more RAP, so recycled asphalt, and to process that you have to heat it up a lot hotter, effectively. So when at the point when it comes onto the screen, it's can be up to 350 degrees centigrade Celsius.
Oh, wow.
So it can be really hot at the point it comes onto the screen, and then a lot of these old screens weren't designed to handle that kind of temperature. So when they're increasing the temperature of the material they're putting on, they're getting lots of bearing failures as a result of the shaft going through the middle of the screen, supported by the bearings, and it's all overheating. The lubrication's getting taken out, and that's been like a massive headache for customers, because it kind of you can't stockpile asphalt. You produce it as the trucks come in to take it out. So if it goes down last minute, it's a massive headache if you've got a load of trucks waiting for asphalt to take on to projects around the country. So the solution to that we've been having like a lot of success with is basically moving the vibrating mechanism above the screen, and using like a pod system where the customer can easily remove the vibrating motors on top of the screen if they ever have a failure. But ideally, the screen's designed with the motors above the screen so that it's out of the zone where the heat's coming, so it's not getting hot material falling on.
So we can't just use the other incline screens that we talked about before. This is a special thing. Okay.
Yeah, you can have a go, but it's an incline screen that you see on like a normal aggregate processing plant. You probably expect the bearings to be operating about 60 to 70 degrees Celsius. I don't know what that is in Fahrenheit, but that would be like normal operating temperatures, and that's just the heat being caused by the friction in the bearing. Whereas on asphalt plants, like I say, you can get material coming onto it that's already, before the friction in the bearing is happening, it's already 350 degrees. So you can lubricate it as much as you want, but if it's getting that hot, you've either got to cool the bearing somehow, or you've got to move it into a place where it's not going to get hot. So that's what we've been doing on these asphalt screens, and it's like a pretty simple modification that you can only really do with a custom bespoke machine, because you're putting it into an old plant. So
yeah, it's a good point. Well, you've done a lot. I know you've done other ones too, but we could probably be here for another hour talking about that. So I think I better cut it off, though. We don't want to go all day, even though it is kind of fun. Now I'm gonna kind of just wrap it up a bit. Thanks, Jack. I appreciate everything, and we talked about a lot today. McClanahan, we offer the proper people to ask these questions. And like we talked, we don't want to give you something that's not going to work. So we have the expertise here to look at your plant, if you want to call it that, and make sure we give you the right tool. And that's what we really offer is expertise and really good equipment too, stuff that's going to last you years, and we can help you. As far as maintenance goes, we're kind of a consultant with you as well, partnership with the customers out there. But hey, that's gonna do it for us for today. And I just want to thank you for listening to Groundwork, McClanahan podcast. Be sure to subscribe on your favorite listening app for the latest updates and new episodes. And thank you.
Thank you.